Hello, friend. I am Neil Tyson, and tonight I will be your guide on a journey to the edge of our understanding. Settle in, let go of the day, and allow your mind to drift outward, past the gentle blue shimmer of our atmosphere, beyond the silent orbit of the moon, a loyal pearl-gray companion. We travel further now, past the warm, glowing embers of Mars and the colossal, swirling storms of Jupiter. We are floating now in the profound and peaceful darkness of the outer solar system. From here, our sun is just the brightest star in a velvet field of countless others. This is the realm of the Oort cloud, a vast theoretical sphere of icy bodies, trillions of them, held in the sun's faintest gravitational embrace. They have been here since the beginning, sleeping relics from the dawn of our solar system, more than 4.5 billion years ago. They are the seeds of worlds, the keepers of cosmic memory, waiting patiently in the cold and the quiet. Every now and then, a gentle nudge from a passing star, a subtle gravitational tide awakens one of these sleeping giants. It begins a long, slow fall, a journey of millions of years, inward toward the distant warmth of the sun. We call these visitors comets, and they are more than just ice and rock. They are storytellers. Each one carries within its frozen heart a pristine sample of the primordial cloud from which our Earth and everything on it was born. And as we listen to their stories, we learn more about our own. Tonight, our story is about one such visitor, a messenger that promised a spectacular show, but delivered instead a beautiful and perplexing mystery. Its name is C/2019 Y4, but it is better known by the name of the system that found it, Atlas. It was not a fiery spectacle, but a whisper, a traveler that journeyed for millennia, carrying secrets that continue to ripple through the minds of astronomers, inviting us to wonder and to rest in the face of the magnificent unknown. So breathe deeply and let us begin our journey with this ghostly visitor from the deep. Our story begins in the final days of 2019. Imagine the robotic eyes of a telescope stationed on a quiet mountaintop in Hawaii, scanning the darkness. This is the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a vigilant guardian designed to seek out objects that might drift too close to our home. On the 28th of December, it flagged a new, faint smudge of light, an object moving with purpose against the backdrop of distant stars. It was given its designation, C/2019 Y4, a simple cosmic catalog number for what was, at the time, an unremarkable discovery. It was incredibly dim, a ghost in the machine, visible only to powerful telescopes. It was just one of many small, icy bodies discovered each year, destined, it seemed, for a quiet and unobserved journey around the sun. Astronomers took note of its path, a long, sweeping orbit that suggested it came from the farthest reaches of the solar system, a true relic of the ancient Oort cloud. They calculated its trajectory, predicted its future brightness, and for a few weeks, Comet Atlas was simply another data point, a faint whisper in the cosmic dark. But then, something extraordinary began to happen. In the quiet solitude of space, as Atlas drifted closer to the sun, it began to change. The faint smudge started to glow. It wasn't a slow, predictable awakening. It was a surge, a bloom of impossible light. Cometary brightness is a gentle science of prediction. As a comet nears the sun, its ices begin to sublimate, turning directly from solid to gas, releasing dust and creating a fuzzy atmosphere called a coma. This coma reflects sunlight, and the closer the comet gets, the more active it becomes and the brighter it appears. There are formulas, models based on thousands of observations that tell us how a typical comet should behave. Comet Atlas followed none of them. It defied every projection. In January and February of 2020, its brightness increased by a staggering amount, a factor of several hundred. By March, it had brightened by a factor of thousands, an almost unheard-of surge for a comet still so far from the sun. Imagine you are standing in a field on a moonless night, looking up at a familiar constellation. Night after night, you see the same steady points of light. Then, one of those points, one you hadn't even noticed before, begins to grow. First, it's a faint suggestion of light. Then it rivals the dimmer stars. Soon it's as bright as the most prominent stars in the sky, a soft, ethereal greenish glow where there was once only darkness. This is what astronomers were witnessing through their telescopes. The comet was transforming from an obscure object into a celestial superstar. The news spread like wildfire through the astronomical community and then to the public. This was it. This was the one we had been waiting for.
The calculations suggested that if it continued this trend, by the time it made its closest approach to Earth in May, Comet Atlas could become brilliantly visible to the naked eye, perhaps even rivaling the planet Venus in the twilight sky. It was heralded as the potential comet of the generation, a spectacular celestial event that would grace our skies and inspire awe in millions. The excitement was a palpable thing, a shared sense of anticipation for a rare and beautiful gift from the cosmos. But beneath the excitement, a question lingered, a quiet, persistent whisper. What was powering this incredible flare? This wasn't the gentle sigh of a comet waking up. This was a roar. It was as if a deep-sea creature, accustomed to the crushing dark, had suddenly activated a dazzling bioluminescence, a beacon of impossible intensity. Something unusual was happening within the heart of this icy traveler, a process that was driving it to shine with a brilliance that its size and distance simply could not explain. The ghost had found its voice, and it was singing a powerful, beautiful, and ultimately unsustainable song. And as we watched, captivated by the light, we had no idea we were witnessing not a grand arrival, but the beginning of a profound and elegant disappearance. Every object in our solar system travels along a path determined by gravity, an invisible groove carved into the fabric of space-time. These orbits are like celestial fingerprints, unique to each planet, asteroid, and comet. And when astronomers calculated the orbit of Comet Atlas, they uncovered a startling connection, a deep echo from the past. Its path through the heavens was almost identical to another, much older visitor, the Great Comet of 1844. Imagine for a moment the world in that year. The skies were darker, free from the glow of modern cities. People looked up and saw a brilliant comet with a long, graceful tail stretching across the constellations. It was a source of wonder and speculation, a celestial wanderer that captivated observers for weeks before it faded back into the void. For over 175 years, it was just a memory, a record in old astronomical logs. And now, a new comet had appeared, following that very same ghost path through the solar system. This was no coincidence. In the grand scheme of the cosmos, such an identical trajectory is a clear sign of a shared origin. It meant that Comet Atlas and the Great Comet of 1844 were siblings, two pieces of a much larger, grander object that had met its fate long, long ago. We can picture it, perhaps 5,000 years in our past, a truly colossal parent comet, many miles across, making its own journey toward the sun. As it warmed, stresses began to build within its icy heart. Perhaps the sun's gravity pulled on it, or perhaps jets of gas erupted from its surface, causing it to spin. Whatever the cause, this ancient giant fractured, breaking into multiple pieces. It did not explode in a single violent event. Instead, it gently came apart, and its children, each a significant comet in its own right, continued to travel along the same path, but slightly separated, like a string of pearls slowly drifting apart over the millennia. The Great Comet of 1844 was one of those children. Comet Atlas was another. This revelation transformed our view of the object. It was no longer a solitary visitor, but a piece of a much larger puzzle, a fragment of a lost dynasty. It was returning to a place its ancestor had known, a path blazed long before. This idea of a comet family adds a profound sense of history and time to our understanding. It's a reminder that the events we witness in our lifetimes are often just single moments in a story that spans eons. The light from Atlas was not just reflected sunlight. It was the light of memory, an echo of a breakup that occurred when human civilizations were just beginning to build their first cities. And it raised a tantalizing question. If these two were siblings, were there others? Are there more fragments of this lost giant still out there, sleeping in the dark, waiting for their turn to fall toward the sun and reveal their shared heritage? Atlas's impossible brightness now had a possible context. Perhaps its spectacular flare-up was related to its lineage. Perhaps these fragments were inherently unstable, prone to these brilliant but fleeting displays. The ghost in the sky was now part of a ghost story, a tale of a great family torn asunder, its children returning one by one to remind us of what was lost. We were not just watching a comet, we were watching a chapter of a multi-generational epic unfold in the quiet theater of the night sky. As astronomers tried to understand the comet's strange behavior, their attention turned to its very core, to the mysterious engine powering its outburst, the nucleus. When we think of a comet's heart, we might imagine a solid, singular object, a dirty snowball of ice and rock packed together under immense pressure. This is a fine model for many comets, solid bodies that can withstand many trips around the sun. But as Atlas grew brighter and brighter, evidence began to suggest that its nucleus was anything but solid. It was likely something far more delicate, far more ephemeral. The emerging theory was that Comet Atlas was not a cohesive rock, but what scientists call a rubble pile, or perhaps even more poetically, a body of primordial fluff. Imagine gathering a handful of freshly fallen snow. It's light, airy, and you can easily crush it into a solid ball. Now, imagine a structure held together with the same gentle force as that untouched snow, a loose aggregation of ice grains and dust particles barely clinging to one another. This is the modern picture of Comet Atlas's heart. It wasn't forged in fire and pressure, but gently assembled in the freezing calm of the outer solar system, billions of years ago. Tiny frozen particles of water, carbon monoxide, and other gases, mixed with specks of cosmic dust, slowly came together, drawn by their own minuscule gravity. The resulting body was not a solid object, but a porous, fragile agglomeration, perhaps more like a piece of spun sugar or a delicate meringue than a rock. It was a cosmic antique, exquisitely preserved in the deep freeze of space, its structure a window into the gentle conditions of the early solar system. This inherent weakness was likely both the secret to its brilliance and the seed of its own undoing. As this fluffy nucleus drew nearer to the sun, the gentle warmth didn't just warm the surface, it penetrated deep into the porous interior. Trapped gases, frozen for billions of years, began to sublimate all at once, from countless tiny pockets and fissures throughout the nucleus. This wasn't a surface-level event, it was the whole body waking up, outgassing from the inside out. This would explain the incredible surge in brightness. The comet was shedding dust and gas at a furious rate, creating an enormous coma that beautifully reflected sunlight, giving the impression of a much larger, more solid object. It was, in a way, consuming itself to create its spectacular glow. The very thing that made it so captivating to watch was the process of it falling apart. It was like a magnificent ancient manuscript, its pages turning to dust even as we tried to read them. This fragility also deepened the connection to its sibling, the Great Comet of 1844, and their lost parent. It was likely that the original, massive comet was also a loosely bound structure. Its breakup was not a violent shattering, but a gentle crumbling, sending its fluffy children on their long, separate journeys. Atlas was simply following the family tradition. It was born of fragility, and it was destined to live a life of fleeting, fragile beauty. The light we saw was the glow of its own graceful dissolution. For weeks, the celestial show only grew more promising. Comet Atlas continued its magnificent brightening, its light curve a steep upward climb that fueled dreams of a truly historic naked-eye spectacle. The astronomical community and sky-gazers around the world watched, holding a collective breath. And then, in the middle of March 2020, the story took a sudden, unexpected turn. The comet stopped getting brighter. The steep upward curve on the graphs suddenly and inexplicably flattened out. For a few days, it held steady, a plateau in its performance that was puzzling but not yet alarming. Perhaps it was a temporary lull, a pause before an even greater surge. But the pause lingered, and then the light began to fade. The decline was subtle at first, but unmistakable. The great harbinger was dimming long before it should have. This was the first sign of trouble, the first clue that the performance was not going to proceed as planned. Telescopes around the world, both professional and amateur, turned their lenses toward the fading comet, trying to understand what was happening. And in early April, they saw it. The images returned were no longer of a single, condensed point of light surrounded by a soft, symmetrical coma. Instead, the core, the very heart of the comet, appeared fuzzy, elongated. It was as if a perfectly focused star had suddenly blurred, its crisp definition lost. This was the moment of revelation, the first clear photographic evidence that the solid nucleus of Comet Atlas was no more. The engine had failed. The single, loosely bound heart had given way under the gentle, persistent pressure of the sun's warmth. The beautiful ice sculpture had developed a fatal internal crack. Imagine the sound of a low, resonant hum, a vibration of cosmic stress that had been building within the comet for weeks. That hum had now fallen silent. The tension was released. For weeks, the celestial show only grew more promising. Comet Atlas continued its magnificent brightening, its light curve a steep upward climb that fueled dreams of a truly historic naked-eye spectacle. The astronomical community and sky gazers around the world watched, holding a collective breath. And then, in the middle of March 2020, the story took a sudden, unexpected turn. The comet stopped getting brighter. The steep upward curve on the graphs suddenly and inexplicably flattened out. For a few days, it held steady, a plateau in its performance that was puzzling but not yet alarming. But the pause lingered, and then the light began to fade. The decline was subtle at first, but unmistakable. The great harbinger was dimming long before it should have. This was the first sign of trouble, the first clue that the performance was not going to proceed as planned. Telescopes around the world, both professional and amateur, turned their lenses toward the fading comet, trying to understand what was happening. And in early April, they saw it. The images returned were no longer of a single, condensed point of light surrounded by a soft, symmetrical coma. Instead, the core, the very heart of the comet, appeared fuzzy, elongated. It was as if a perfectly focused star had suddenly blurred, its crisp definition lost. This was the moment of revelation, the first clear photographic evidence that the solid nucleus of Comet Atlas was no more. The engine had failed. The single, loosely bound heart had given way under the gentle, persistent pressure of the sun's warmth. The beautiful ice sculpture had developed a fatal internal crack. Imagine the sound of a low, resonant hum, a vibration of cosmic stress that had been building within the comet for weeks. That hum had now fallen silent. The tension was released. The show we were anticipating, the rise of a brilliant comet in our evening sky, was transforming, minute by minute, into a different kind of spectacle. A scientific puzzle, a slow-motion study of a celestial object coming undone. The initial excitement was replaced by a quiet, intense curiosity. The promise of a great spectacle was gone, but in its place was a mystery that was, in many ways, even more compelling. We were no longer just spectators. We were now witnesses to the graceful and silent death of a comet. The great unraveling had begun. The blur was the first chapter of the next story. That soft, elongated core was not a single object in distress, but a community of objects, a family of ghosts suddenly revealed. The view from earthbound telescopes was intriguing, but the true nature of this graceful dissolution was revealed by our most powerful eye in the sky, the Hubble Space Telescope. In late April of 2020, Hubble was directed to gaze at the fading comet, and what it saw was breathtaking. It was not one elongated blur, but a procession, a string of icy phantoms, each a miniature comet in its own right, moving in silent, stately formation. The comet's heart had not just cracked, it had shattered into a cascade of fragments. Scientists began to catalog them, giving them simple, unassuming names. There was fragment A and B, C and D. At least 4 main pieces, each a distinct point of light, were clearly visible, each wrapped in its own tiny personal coma of gas and dust. But the story was more complex than that. Over the following days, Hubble's steady gaze revealed even more. Dozens of smaller pieces, some estimated to be no larger than a house, were scattered amongst the main fragments, a trail of celestial breadcrumbs. The breakup had not been a single instantaneous event. It was a slow, staggered unraveling, a process that had likely unfolded over many days, perhaps even weeks. Imagine a necklace of flawless, shimmering pearls, and imagine that the thread holding them together does not snap, but slowly, fiber by fiber, dissolves. First, one pearl drifts gently away. Then, a few hours or a few days later, another follows. Then a cluster of smaller beads come loose, each one finding its own slight deviation from the original path. This is what we were witnessing, millions of miles away. A graceful, silent, and sequential dissolution. It was a ballet of celestial mechanics. The fragments were not flying apart violently. They were separating from each other with the most gentle of motions, drifting at about the walking pace of a person. In the vastness of space, this slow separation was enough to create a beautiful, ever-widening train of light against the black. This staggered breakup presented a profound new mystery. Why did it happen this way? Why not all at once? The answer may lie hidden within the very structure of the comet, in its ancient and layered history. Perhaps the nucleus was not a uniform ball of fluffy ice, but was built in layers like an onion. As the sun's warmth penetrated the first, most fragile outer layer, it peeled away. The new exposed surface was then subjected to the same gentle heat, and in time, it too gave way. Or perhaps it was a chain reaction. A jet of gas erupting from one weak spot could have created a stress that caused a nearby area to fracture, releasing more gas, which in turn destabilized another section. A cascade of small internal events, rippling through the delicate structure until the entire body had surrendered its form. We may never know the precise sequence of events, but we can imagine it. A silent, internal crumbling, a whisper of a fracture spreading through the primordial ice, releasing these ghosts, one by one, to embark on their own final, fleeting journey toward the sun. For a brief time, we saw not one comet atlas, but many, a whole family of comets, each a memory of the larger whole, trailing across the solar system in a final, beautiful, and profoundly peaceful funeral procession. So we are left with a quiet cascade, a string of pearls coming undone. But what was the force that snapped the first thread? What initiated this gentle unraveling? The leading suspect is not some external violent collision, but a force born from within the comet itself, a story of self-destruction, driven by the very warmth that was bringing it to life. It is a theory known as rotational spin-up, and it paints a picture of a deadly cosmic pirouette. Let us imagine our fragile, fluffy nucleus, a loose collection of ice and dust, drifting through the cold. As it gets closer to the sun, its surface begins to warm. Ices that have been frozen solid for billions of years begin to sublimate, turning directly from a solid into a gas, skipping the liquid phase entirely. This gas doesn't just seep out uniformly. It erupts from specific vents or fissures on the surface, weak spots where the ice is more volatile.
These eruptions create jets of gas and dust streaming away from the nucleus. Now, picture a simple pinwheel or a rotating lawn sprinkler. The force of the air or the water pushing out in one direction causes the object to spin in the other. These gas jets on the comet's nucleus act in exactly the same way. They are tiny, natural thrusters. If they were perfectly balanced on all sides of the nucleus, they might not have much effect. But a comet's surface is not perfect. It is a lumpy, uneven landscape of valleys, cracks, and craters. So the jets fire from random, unbalanced positions. One jet might push from the North Pole, another from near the equator. And the cumulative effect of these tiny, uneven pushes is to start the nucleus spinning. At first, the rotation would be imperceptibly slow. A gentle turn, taking perhaps days to complete one full rotation. A slow, graceful waltz in the silent dark. But as the comet drew nearer to the sun, the heating would intensify. More jets would erupt, and the existing ones would grow stronger. The force of these thrusters would increase, and so would the rate of the spin. The slow waltz would become a steady turn, then a faster spin, then a dizzying pirouette. The comet was spinning itself faster and faster, caught in a feedback loop of sunlight and sublimation. And as it spun, another force came into play, centrifugal force. It is the same force that pulls you to the side when you round a corner in a car, or the force that keeps water in a bucket when you swing it over your head. It is a force that pulls outward, away from the center of rotation. For a solid rocky body, this force is easily overcome by its own internal strength. But Comet Atlas was not a solid body. It was a fragile construction, a rubble pile, a collection of primordial fluff held together by the weakest of gravitational and chemical bonds. As the spin rate increased, the outward pull of centrifugal force began to overwhelm the gentle forces holding the comet together. Imagine that spinning handful of light snow. As it spins faster, the delicate flakes on the outside would begin to fly away. The same was happening to Atlas. The strain on its fragile heart became unbearable. It reached a critical speed where it could no longer hold itself together. And so, it simply let go. The deadly pirouette had reached its crescendo, and the comet tore itself apart from the inside out. It's a beautifully poetic and somewhat tragic end. The very thing that gave the comet its brilliant glow, the outgassing of its ancient ices, was the very thing that drove it to its own destruction. It was not slain by the sun's fire, but by the gentle, insistent pressure of its light, a warmth that coaxed it into a spin from which it could not recover. This brings us to one of the deepest and most perplexing aspects of the entire story of Comet Atlas. It is not just how it broke apart, but where. The great unraveling, the deadly pirouette, it all happened so very far from the sun. When Atlas began to fragment in April of 2020, it was more than 90 million miles from the sun, a distance that placed it beyond the orbit of our own planet, Earth, and still approaching the orbit of Mars. In the life of a comet, this is still the cold, distant suburbs of the solar system. The sun from that distance is a brilliant, powerful star, but its heat is not yet the overwhelming, destructive force it will become closer in. Most comets at this range are just beginning to awaken, their activity slowly ramping up for their grand solar passage. For a comet to completely disintegrate this far out is unusual. It is, in fact, almost unheard of. To truly appreciate how strange this is, we must consider the journeys of other comets. There is a special class of them known as sun grazers. These are the most daring of all celestial travelers. Their orbits take them breathtakingly close to the sun, flying through its outer atmosphere, the corona, where temperatures reach millions of degrees. They are subjected to the most extreme thermal and gravitational stresses imaginable, and yet many of them survive. The famous comet Lovejoy in 2011 flew just 87,000 miles above the sun's surface, far closer than the moon is to the Earth, and emerged from the other side, battered but intact, to once again grace our skies. These comets are built of tougher stuff, solid cores of ice and rock that can withstand the inferno. Comet Atlas, by contrast, never even got close to the fire. It fell apart in the relative cool and calm of the outer solar system. It was like a great ship built for a long and arduous sea voyage, suddenly springing 1,000 leaks and sinking while still in the calm waters of the harbor. This premature demise is the most powerful evidence we have for its extreme and still not fully understood fragility. It confirms the picture of a nucleus made not of solid ice, but of the lightest, fluffiest, primordial material, barely held together.
It suggests that Atlas was perhaps one of the most fragile comets ever observed. The gentle warmth it experienced near the orbit of Mars was all that was needed to activate the jets that would spin it into oblivion. It didn't need the full fury of the sun. A cosmic whisper was enough. This adds a layer of pathos to its story. It was a traveler from the deep, undertaking a journey of millions of years, only to collapse from exhaustion long before reaching its destination. Its great promise, its impossible brightness, was a symptom of its fatal weakness. It shone so brightly because it was coming apart so easily. And its story serves as a profound lesson in cosmic humility, a reminder that our expectations, our models, are just sketches of a far more complex and surprising reality. The universe is filled with objects of unimaginable toughness and unimaginable fragility, and we are just beginning to learn how to tell the difference. The comet, as a singular object, was gone. The bright, condensed point of light that had promised such a spectacle had dissolved. But its story was not over. In its wake, it left behind something new, something arguably even more beautiful and scientifically rich. A vast, ethereal trail of stardust and ice. The death of the nucleus was the birth of a ghostly new structure, a celestial river of debris that continued to follow the comet's original path. The aftermath of the breakup was not an empty space, but a transformation. Without the central gravitational anchor of the nucleus to hold them, the countless particles of dust and ice that had made up the coma and the core began to drift apart. They spread out, thinning into a translucent, shimmering cloud, an elongated autopsy report written in characters of dust and sunlight, stretching for millions of miles. Astronomers turned their telescopes to this ghostly trail, and what they saw was a fascinating laboratory for cometary science. Before the breakup, all they could study was the combined light from the coma, a fuzzy average of all the material being shed. Now, they could study the individual behavior of the fragments and the properties of the dust itself. The tail became the main character in the story. A comet typically has two tails. There is the ion tail, made of gases energized by the solar wind, which always points directly away from the sun. And there is the dust tail, made of larger, heavier particles that are pushed more gently by the pressure of sunlight itself. This dust tail is often curved, lagging behind the comet in its orbit. After Atlas disintegrated, this dust tail became the dominant feature. It was no longer being replenished by a single active nucleus, but was now a coasting cloud, a memory of what had been. By observing how this cloud of dust reflected and scattered sunlight, scientists could deduce the size of the particles within it. They found that Atlas was rich in relatively large dust grains, some a millimeter in size, which is quite chunky for a comet. This might be another clue to its fragile nature. It wasn't just made of fine smoke-like dust, but of larger aggregates that could easily break apart. Watching this celestial smoke ring expand was like watching a replay of the comet's formation, but in reverse. The material that had gently come together 4.5 billion years ago was now gently dispersing, returning to the cosmos. Imagine a single sunbeam slanting into a quiet room, illuminating a swirling universe of tiny dust motes. Now imagine that sunbeam is millions of miles wide, and the dust motes are the pristine, primordial building blocks of planets. This was the sight that Atlas left behind. It was a soft, ethereal texture painted across the black canvas of space, a translucent curtain of stardust. There was a profound sense of peace in it. It was not a violent end, but a release. The comet did not die. It was simply reconfigured. It had given up its singular identity to become a diffuse and beautiful part of the solar system's background glow, a faint and shimmering memory of a journey that began long ago in the silent, frozen darkness. The light from that dispersing cloud of stardust carried more than just a reflection. It carried a message, a recipe. To understand it, we must journey into the light itself, to witness a process of cosmic alchemy.
When astronomers want to know what a distant star or comet is made of, they can't simply travel there and take a sample. Instead, they practice a kind of magic, a science called spectroscopy. They capture the faint light from the object and pass it through an instrument, like a prism or a diffraction grating, that splits the light into its constituent colors, a rainbow. But it is a rainbow with a secret code. Woven into this spectrum of colors are tiny, dark lines, or sometimes bright, glowing lines. These are absorption and emission lines, and each one is a fingerprint, a unique signature left behind by a specific chemical element or molecule. Every substance in the universe, when heated, absorbs and emits light at its own characteristic set of frequencies. By reading these lines, we can know, with incredible certainty, the chemical makeup of an object that is millions of miles away. It is as if the comet is whispering its own recipe to us across the void. So, astronomers listened to the light of Comet Atlas. They decoded the light's alchemical fingerprint, both during its brilliant outburst and after its serene dissolution. The light revealed the familiar ingredients of a comet from the Oort cloud. There was the signature of water, the fundamental ice that forms the bulk of a comet's body. And there was the whisper of more exotic substances. Cyanogen, a simple molecule of carbon and nitrogen, was present. This molecule, when energized by sunlight, glows with an ethereal green light and is responsible for the beautiful emerald hue we see in the comas of many comets. They also found diatomic carbon, two carbon atoms bonded together, another contributor to that classic cometary glow. These were the standard ingredients, the expected components of a primordial cosmic recipe. But the true story, as with any great recipe, is not just in the ingredients, but in their proportions. And here, Comet Atlas began to hint at its unique character. Some studies suggested that Atlas was what we call carbon chain depleted. It seems to have fewer long-chain carbon molecules than many other comets we have observed. This is a subtle clue, a quiet detail in the cosmic song, but it might be a significant one. Carbon is a wonderful building block. It forms complex, sticky organic molecules that can act as a kind of cosmic glue, helping to hold the dust and ice of a comet's nucleus together. If Atlas was indeed deficient in this material, it would help to explain its profound fragility. It was a body built without enough of the essential mortar to hold its icy bricks together. Furthermore, astronomers studied how the comet's chemistry changed as it broke apart. They observed the fragments and noticed that some pieces seemed to release different mixtures of gas and dust than others. Fragment A might have a slightly different chemical breath than fragment B. This observation supports the idea of a layered or uneven composition. The comet was not a perfectly mixed bowl of ingredients. It was a heterogeneous body, with pockets of different ice and dust, a chemical landscape that reflected its long and gentle formation in the ancient solar nebula. As it spun and fractured, it revealed these different internal regions, each releasing its own unique alchemical signature into space. Imagine light not as a wave, but as a chord of music. Each molecule adds its own note to the chord. Most comets play a familiar harmonious tune. Comet Atlas played that tune, but perhaps with a few notes missing, a few tones slightly out of balance. It was this subtle dissonance in its composition, this unique recipe, that was intrinsically linked to its fate. Its chemical makeup dictated its structure dictated its fragility, and its fragility dictated its beautiful, premature, and ultimately enlightening end. We did not just see a comet. We were allowed, for a brief time, to read the pages of its primordial recipe book, and, in doing so, we learned a little more about the subtle art of building worlds. This unique recipe, this echo of a shared orbit with a comet from 1844, all points back to a single profound mystery: the lost giant. If Atlas and the Great Comet of 1844 are siblings, two fragments from a larger body, then they are the scattered clues to a much grander story, the story of their parent. We are like cosmic archaeologists, stumbling upon two related artifacts, knowing they must have come from a long-lost city, a magnificent progenitor that we have never seen. And so we ask the question, what was this parent comet, and where is the rest of its family?
Based on the size of the known fragments and the amount of dust they released, we can begin to imagine this lost giant. It must have been a truly colossal object, perhaps 60 miles across or more, a true monarch of the Oort cloud. A body of that size, had it arrived in the inner solar system intact, would have been one of the most spectacular sights in all of human history. A celestial spectacle rivaling the full moon, its tail stretching from horizon to horizon. But it never arrived. Instead, the story suggests that sometime in the distant past, perhaps 5,000 years ago, this giant met its end. As it made a previous pass through the solar system, the stresses of the sun's gravity and warmth became too much for its fragile structure, and it gently crumbled apart. It was not a violent explosion, but a quiet, majestic dissolution, a king abdicating its throne.
The event would have been completely invisible from Earth, a silent breakup in the cold darkness of the outer solar system. But it sent its children, its heirs, on that same long, looping path, fated to follow one another back toward the sun over the course of millennia. We have now met two of them, two siblings separated by 176 years. But surely a body 60 miles across would not break into only two significant pieces. There must be others, dozens, perhaps hundreds. Where are they? The search for the rest of this lost family is one of the most tantalizing and difficult challenges in astronomy. Most of these fragments would be dark, inert, and completely dormant as they travel through the freezing depths of the outer solar system. They would be colder than liquid nitrogen, reflecting almost no sunlight, making them effectively invisible to our telescopes. We would have almost no chance of finding them until they, too, begin their final fall toward the sun and start to glow. It is a cosmic game of hide-and-seek played out over thousands of years. We are standing on the shore, watching for ships to emerge from a vast, dark ocean. We have seen two. Are there more just beyond the horizon? The search involves a kind of celestial forensics. Astronomers can precisely model the orbit of Atlas and the 1844 comet and then run those models backward in time, trying to reconstruct the breakup event and predict the paths of other potential fragments. They scan the skies along this ghost orbit, this invisible cosmic highway, looking for any faint objects that do not belong. So far, no other major family members have been definitively identified. The rest of the siblings remain lost in the darkness. It evokes a sense of vast emptiness, of a great story with most of its pages missing. We are left to wonder, is there another fragment on its way right now, due to arrive in 100 or 1,000 years? Will our descendants look up to see a new brilliant member of the Atlas family gracing their skies? The riddle of the parent body is a profound reminder of the limits of our vision. The universe is not just what we see. It is also filled with the ghosts of what was and the promise of what is yet to come. The silent, scattered family of Comet Atlas drifts on, a testament to a lost giant waiting for their turn to whisper their story to the light. And what of the children we did see? What of fragments A, B, C, and D, and the dozens of smaller pieces that followed them? What is their final fate? Their story transitions from one of dissolution to one of diffusion, a gentle fading into the background hum of the cosmos. This is the final chapter for the debris, the journey into invisibility. After the breakup, each fragment, for a short time, acted like its own miniature comet. Each had a small fuzzy coma and a faint tail. But they were small, house-sized chunks of ice and dust, and they did not have the gravitational strength or the sheer volume of material to sustain this activity for long. They were like cosmic embers, glowing brightly for a moment after the fire has gone out, but destined to fade. As they continued their journey around the sun and back out into the cold, they continued to sublimate and shrink. Their remaining ices turned to gas and drifted away, and the dust particles held within them were released. Without the gravitational anchor of a large central nucleus, there was nothing to hold this cloud together. Imagine placing a single drop of ink into a vast, still ocean. At first, it is a concentrated, dark cloud, but slowly the currents begin to pull at it. It swirls, thins out, and spreads, its edges becoming soft and indistinct. In time, its molecules disperse so widely that you can no longer distinguish the ink from the water. The drop is not gone, its essence is still there, but it has become one with the ocean. This is the final journey of the debris of Comet Atlas. The cloud of fragments and dust that was once a single cohesive object is now being gently pulled and stretched by the subtle forces of sunlight and planetary gravity. The fragments themselves are fading to black, their last volatile ices exhausted, becoming dark, inert chunks of cosmic dust and rock. The dust they released is spreading out even more thinly, becoming a vast, diffuse river of particles, an invisible trail that marks the comet's orbit. From our vantage point on Earth, this fading is a slow and profoundly peaceful process. We watched through our telescopes as the fragments grew dimmer and dimmer, their separation from each other growing wider and wider, until eventually, one by one, they faded below the limit of our detection. They melted back into the night, their light reabsorbed by the velvet darkness from which they came. Will we ever see them again? The larger fragments, now dark and silent, will continue on their immense multi-thousand-year orbit.
They will return to the vicinity of the Sun, but they will likely be too small and too depleted of ice to ever put on a show again. They will be true ghosts, passing by unseen. The vast cloud of dust they left behind will continue to spread along the entire length of the comet's orbit. Over many thousands of years, it will become a faint, tenuous tube of debris, a meteoroid stream. It is possible that one day, Earth's orbit might intersect with this stream, and our descendants might witness a new, gentle meteor shower, a sprinkle of cosmic dust burning up in our atmosphere. Each shooting star, a tiny, final farewell from a piece of Comet Atlas, a last flicker of light from a journey that began billions of years ago. This is the ultimate cosmic recycling. The comet's substance is not lost. It is simply returned to the solar system, becoming an indistinguishable part of the zodiacal light, that faint, hazy band of light in the night sky, which is itself the combined glow of countless dust particles from countless other comets that have lived and dissolved before. It is a beautiful meditation on letting go, a journey not to a destination, but back to the beginning, a peaceful return to the silent, star-filled void. And so we arrive at the final truth of Comet Atlas. It is a story that ends not with a grand finale, but with a quiet, philosophical reflection, a lesson in cosmic humility. We began this journey with an expectation, a promise of a comet of the generation. We prepared our telescopes and our hearts for a brilliant spectacle, a bright beacon in the twilight sky that would unite us in shared wonder. And that is not what we received. By that measure, the comet was a failure, a disappointment. But this is a limited human-centric view. In the grander scheme, Comet Atlas was not a failure at all. It was an unexpected gift. It was a far richer, far more profound scientific lesson than any bright, predictable comet could ever have been. It taught us, first and foremost, that our models are incomplete. Our ability to predict the behavior of these wild, primordial objects is still in its infancy. The universe is not a simple machine that always follows our neat equations. Atlas defied our brightness predictions, it shattered our assumptions about cometary structure, and it disintegrated in a place we thought was safe. It reminded us that the cosmos is always more clever, more complex, and more surprising than we imagine. It showed us the humbling and beautiful truth that there are vast gaps in our knowledge. And that is a wonderful thing, because it is in those gaps, in those moments when our predictions fail, that true discovery happens. The unexplained is the frontier of knowledge. Atlas was not the answer we expected, but it forced us to ask much better, much deeper questions. It also gave us an unprecedented front-row seat to a process that is fundamental to the evolution of our solar system, the death of a comet. We witnessed in exquisite detail the cascade of fragmentation, the spin-up, the staggered release of its primordial heart. These events happen all the time in the quiet darkness of space, but rarely are we able to watch one so clearly from beginning to end. Atlas became a laboratory, a controlled experiment in cometary physics. And the data it provided will be studied for decades, refining our understanding of how these icy bodies are built and how they ultimately return their substance to the cosmos.
And finally, on a deeper level, Comet Atlas taught us that there is a profound and serene beauty in the ephemeral, in the things that do not last. We are often drawn to the permanent, the brilliant, the strong, but Atlas was none of those things. It was fragile, fleeting, and ultimately it dissolved into a whisper. Its story is a testament to the fact that the most delicate things in the universe can also be the most illuminating. Its brilliant flare was the flash of its own undoing, a brief, glorious moment of existence made possible only by its inherent fragility. It was a cosmic firefly, burning its brightest just before its light went out. The story of Comet Atlas is an unwritten ending. It did not fill the sky with light, but it filled our minds with wonder. It left us not with a memory of a great spectacle, but with a deep and abiding appreciation for the beautiful, unpredictable, and mysterious nature of the universe we are so privileged to inhabit. It is a tribute to the process of discovery itself. It is a quiet invitation to look up at the night sky, not just for the answers, but for the questions. To find peace not in what we know, but in the magnificent, endless expanse of what we have yet to learn. And so, our journey with this cosmic ghost comes to a gentle close. The trail of its dust is now faint, a whisper of a whisper, spread so thin across the vastness of its orbit that it has become one with the quiet light of the solar system.
Let your awareness drift back now, from that distant, silent path, back past the quiet orbits of the outer planets, back toward the soft, blue glow of home. Feel yourself returning to this moment, to the comfort and the safety of your room, to the gentle stillness of your bed. The story of Comet Atlas was not the one we expected to tell. It was not a tale of fire and brilliance, but one of profound and graceful surrender. A traveler from the dawn of time that journeyed for millions of years, not to give us a great spectacle, but to show us a beautiful mystery. It taught us that the most fragile things can hold the deepest truths. It reminded us that the universe is not always loud, that its most important stories are often told in the quietest of voices. It was a fleeting, beautiful puzzle that graced our skies, and its pieces have now returned to the cosmos from which they came. And just as the comet dissolved, letting go of its form to become a peaceful river of stardust, you too can now let go. Let go of the day. Let go of every thought, every worry, every plan. Feel them dissolving, becoming as soft and as distant as that comet's tail. Your mind, too, can find its own peaceful dissolution into the deep and restful quiet of sleep. There is only the gentle rhythm of your breathing now. A slow, easy breath in, filling you with calm. A long, soft breath out, releasing everything. The comet has let go, and now you can too. Feel the weight of your body, a comfortable, pleasant heaviness, sinking softly into the surface beneath you. Feel the quiet in the air around you, a deep, peaceful silence, the same silence that fills the vast spaces between the stars. You are a part of that quiet, a part of that peace. There is nothing left to do, nowhere left to go, only this gentle journey inward, drifting now, floating on the soft currents of your own breath. The story is over. The sky is dark and filled with a silent, peaceful light, and a deep, profound, and welcoming rest awaits. Sleep now, friend. Sleep.